In today's lesson, we're going to begin discussing what are called trigonometric identities. There are 5 main types of basic trigonometric identities, or trig identities. The reciprocal identities, which we have already seen when talking about graphing trig functions and the unit circle. Quotient identities that we have sort of discussed briefly in our class so far, and then the Pythagorean identities, which we will introduce today. Just to give you a basic idea of what an identity is and what that word means, an identity is something that is true for any given value. So for example, I might have the statement that x squared plus 6x plus 8 is equal to x plus 2 times x plus 4. This is an identity because what that means is that the left-hand side is always equal to the right-hand side for any given value of x. So, now that we know kind of what an identity is, let's take a look at our 3 main types of basic trig identities that we will look at in this particular class. We have the reciprocal identities first. These identities are based on the idea that our 3 trig functions that we learned about in geometry and then began discussing again here in pre-cal all have reciprocals. And so, for example, sine of theta is equal to 1 over the cosecant of theta because sine of theta and cosecant of theta are reciprocals of one another. Similarly, we can say that cosecant theta is the same as 1 over the sine of any angle theta. Cosine and secant are reciprocals of each other, so we can say that cosine of theta is the same as 1 over secant of theta, and similarly, secant of theta is the same as 1 over the cosine of theta. And then finally, tangent and cotangent are reciprocals of one another. And so this leads us to these 6 reciprocal identities. But really what you just need to remember is that sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. We also have the quotient identities. The first one says that sine theta divided by cosine theta is just equal to tangent of theta. Then, because tangent and cotangent are reciprocals of each other, we have this second quotient identity that cosine of theta divided by sine of theta is equal to the cotangent of theta. Notice that in order to get this identity, all we did was take the reciprocal of both sides of this first identity. And we tend to do that a lot, where we take a given or known identity and we rearrange it somehow to get a new identity based on that original one. Then finally, we have the Pythagorean identities. This says that sine squared theta plus cosine squared of theta is equal to 1. We then have these other 2 versions of the Pythagorean identity, and I'm going to briefly show you that we can actually derive these 2 Pythagorean identities as long as we remember the first one. And so for my first example of this idea, if I take sine squared theta plus cosine squared theta is equal to 1, and I divide that by cosine squared of theta for each term, then what that's going to give me then is sine squared over cosine squared. Well, I know by a quotient identity based on this one that that is just going to equal to tangent squared of theta. The reason I can say that it's tangent squared is because both of these have squareds on them. So sine squared over cosine squared will become tangent squared. Then cosine squared divided by cosine squared is just going to be 1. And then 1 over cosine squared, we know that 1 over cosine is secant, and so therefore 1 over cosine squared is going to be secant squared of theta. And so what you can see is that this new identity that I found by dividing by cosine squared to this first identity right here matches up with this one here. We can also do the same thing, so sort of example number 2 here, if we take that first identity, sine squared theta plus cosine squared theta is equal to 1, and we divide everything by the sine squared of theta. Well, in that case, sine squared divided by sine squared will reduce to 1. Cosine squared divided by sine squared, using this quotient identity right here, is going to be cotangent squared of theta, and then 1 over the sine squared of theta, going back to this reciprocal identity here, is going to be the same thing as cosecant squared of theta. And so again, we can see that this matches up perfectly with this third identity right here. And so to tell you the truth, I don't really even have these memorized. I have this one memorized along with these super basic ones in the first two boxes, and whenever I need to use one of these, I just derive them using the method that I just showed you. And so now if we look at example 1 and 2, what I want us to do is write two different trig identities based on this first Pythagorean identity, namely sine squared theta plus cosine squared theta is equal to 1. And the reason I want us to do this is because we're going to need to be able to see this identity in a rearranged form. And so what I want to first of all do is isolate sine squared of theta in that identity. And so that means to get it by itself. And so if I take sine squared of theta and I want to get it by itself, that means that I need to take cosine squared of theta and move it to the other side so that it becomes 1 minus the cosine squared of theta. And so what I want you to get good at is training your eyes that whenever you see 1 minus cosine squared, you recognize that as sine squared of theta based on this first Pythagorean identity. The other thing that we like to do is we like to isolate cosine squared of theta, and if we do that, that means that we need to subtract over the sine squared of theta. And so when we move that sine squared over to the other side, that's going to give us 1 minus the sine squared of theta. We'll also do the same thing with our second Pythagorean identity. And so if I were to isolate tangent squared of theta, then what that means is that I would move over the plus 1 there. And so that would give us secant squared theta minus 1. The other thing that you'll sometimes see is you'll see the 1 isolated. And so if we were to isolate the 1, then that would equal to, taking this tangent squared and moving it to the other side, that would equal to secant squared theta minus tangent squared theta. And so these Pythagorean identities can really result in several other identities that you all need to be aware of. And I'll tell you right now that this particular unit on trig identities will go much easier and better for you if you will take the time now to memorize these identities, because if you can quickly identify them, it will make what we're doing a lot more straightforward.